Hi there, everybody. We are still talking about verifying trigonometric identities. I'm on page 434 again, but we've got some more challenging problems for you, so don't let that fool you thinking that it's gonna be easy. So here's question 9. It says sine A minus cos A all squared, blah, 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 right? So, well, first of all, here's my thoughts. I see some potential algebra help right here if I use a pattern on that side, the left there. And over here, I mean, looking at this, I see lots of sines and cosines, and then I see like a single cotan. I have a feeling I'll probably end up like switching that cotan out in terms of its sine or cosine counterparts, using a quotient identity. So first of all, let's work on this left-hand side. I'm going to use the pattern a minus b all squared, which is equal to a squared minus 2ab plus b squared. All right, and if you didn't know that pattern, you could have written this multiplied by itself and then like foiled it or distributed it, whatever you like to call that. So, so this is going to equal sine squared a minus 2 sine a cos a plus cos squared a equals, well, I'll leave the right hand side for now. Does anyone see anything helpful here on this side?
2 sine A plus cosine A.
Oh yeah, I see some squareds. Yeah, so those guys, those are buddies, right? I've got a Pythag identity showing up there. Remember, sine squared theta plus cos squared theta is equal to 1. So it looks like I could switch that out for 1, and I'd have 1 minus 2 sine A cos A equals. And I think that's as far as I'm going to take that for now. Let's see, what about over on this right-hand side? Like I said a moment ago, I think I'm going to switch this out for its quotient identity, right? Because I know that coda is equal to, cos over sine. Right, something like that. Using the quotient identity, so I'll have 1 minus 2 sine squared A multiplied by cosa over sina. So let's see, what cancels out there? Yeah, this sine A cancels out with one of those, leaving 1 behind. So I'll have 1 minus 2 sine A cos A. And I think that sounds verified to me, friends. Sounds verified to me. So that was some algebra showed up, and then two identities right there. So that was kind of the skills required to do number 9. Yeah, we can open the window if we'd like. So let's see. Problem 19. Oh boy, I'm tempted. Let's see. Aha. Yeah, the friction on the window, coefficient of friction, sometimes that mew's a little too low. You can open that up quite a bit and then just hold it in place sometimes. As long as it's not moving, it won't have the momentum to continue sliding down. You know how it is. Yeah. So, all right, guys. So I know I could do some algebra work on the left-hand side here. I know I could cross multiply after doing that. But I'm kind of suspicious about this. Like, I don't know about you, Sam, but are you like super tempted to want to like cancel that out right there?
Because there's addition.
Right, there's addition, but I'm thinking, ready for this? I think, what if I broke this down like this into 2 separate fractions? I don't know. I'm thinking this might be an interesting route. You could possibly have tried cross-multiplying and such, but I don't know if that is necessarily going to be that helpful. It could be. I mean, it could all work out.
Is that even legal?
Right, yeah, that's legal. Well, think about this. The reason that's true is 1 plus, let's see, oh, I'm getting a little bit of lag here. All right, it's coming back. 1 plus 2 all over 3, all right, is the same as 1/3 plus 2/3. All right, that's the idea. So I can do that backwards as well, or whichever way makes sense. So yeah, so I was able to split this up over its common denominator twice. So that seems beneficial because then I get to do this awesome cancel. But what's left over there? Yeah, 1 over 1, which becomes 1. And then here, I'm thinking sec A, cosec A. I think I'm going to replace these with their reciprocal counterparts. So that's going to be 2 over 1 over cosa times 1 over sine, and then plus 1. And I don't know if you guys realize this, I can multiply by those reciprocals of these guys, and I'll get 2 cos A sine A, or sine A cos A. I don't know if you want to work in the other order, plus 1. So I think I've taken the right-hand side kind of as far as I can for a little bit. Yeah, this is a good little trick right there that ended up working out. I'll be interested to see if any of you guys did do the cross-multiply route and see what happened there. Let's see, on the left side, I can use the algebra property again. That's going to be a squared plus 2ab plus b squared. So that's going to be sine squared a plus 2 sine a cos a. Oh, notice where I'm already working. I'm like, aha, aha, right? And then plus cos squared a. And yeah, then you can probably spot that. I mean, once you start seeing those squared trig identities showing up, you should get real suspicious. So this is, yeah, right, I can just replace that with 1, and I have 2 sine a cos a. Plus 1, right? Same idea. And sure, these are switcherooed there, but that doesn't matter. Oh, I left my big circle there. I didn't undo it. Ah, well, that's fine. That's fine. So yeah, I'll check out to see if any of you guys got far doing cross multiplication there. You would have had to cross multiply by this whole thing though at some point, or distribute this denominator by that whole thing. And I'm not sure how convenient that would have been. Let's look at one last example here. Ooh, boy. Yikes. Now I'm seeing multiple fractions, right, is what I'm seeing. So I'm not going to try some cross multiplication trick. But it might be worth finding out what the LCD is. Whew, this is going to be interesting. So let's see, the LCD is equal to what? One minus tanks has to be there because this is a whole denominator. 1 minus cotics, right? So the technique we use for this is multiplying both sides by the LCD. All right, something like that. So let's see, when I multiply it by this, nothing cancels out with the denominator. I have no idea if this is going to be helpful. This is going to be interesting. I wonder if, yeah, because I'm going to have to end up multiplying this out by itself anyway over here, and then by sine x. Should I figure out what this is equal to first before I write it down a whole bunch of times? Let's figure that out. FOIL this out. 1 times 1 is 1. 1 times negative cot x is that. 1 times negative tan x is that. Oh. And negative times a negative is positive. And tan x, did I forget the n there? Tan x times cotan x. Did you guys know that's 1? Yeah, tan x and cotan x are reciprocals of one another. So yeah, so that's going to be 1 there. So this would simplify to be 2 minus cotan x minus tan x. So I might just use this as an alternative for this side, just because I figured I'd pre-simplify some of that. So let's see, multiply this by sine x. I'm going to get that times sine x. I don't even know if I'll have enough room here. Let's see. I'll write it down here. Sine x times 2 minus cot x minus tan x. And then multiplying it by cos x, I'll get the same thing, plus cos x. Guys, I don't think it's going to fit. Oh, man. I need a wider screen. All right. Equals. All right. When I multiply the LCD by this, the 1 minus tanks will cancel out, right? And I'll have cos x multiplied by this. Man, how am I going to even fit that? I don't know, guys. Did you like have to hold your paper sideways to do this problem? This is crazy.
Yeah.
Huh. Oh, guys.
Zoom in and it's like curl it down.
Let's see.
Like
Cos
very good.
x times 1 minus cot x. And then plus sine x, here the 1 minus cot x cancels out, and I'd have sinx times 1 minus tanks. 1 minus tanks. You get the idea. Dot, dot, dot. Tell you what, I'll just write it down here. All right. Whew, wow. Let's just work on this left-hand side for a while. We'll come back to the right-hand side. Unless, do you see anything that immediately cancels out? No, sadly. I can't just like cancel stuff out. So let's see. Let's distribute this sine times those 3. This cosine times those 3. Maybe. And let's see. So this is going to be 2 sinx, right? Minus, let's see, sine x times cotan x. Remember that cotan x is the same as cos x over sinx. So the sinx would cancel out. Yeah, so it's going to just be minus cos x. This problem's so long, I'm doing a whole bunch of simultaneous simplifying here. Just try to make things work a little easier. Tan x, by the way, is the same as sinx over cosx. So when I multiply this, that's going to be minus sine squared x over cosx. Yikes. Plus, all right, let's multiply this. So this will be 2 cosx. Multiplying this, that's going to be minus cos squared x over sine x, because remember this is equal to that, and cos x times the cos, yeah. And then the cos multiplied by the tan is this. The coses would cancel out. I just have minus sine x. Right, right?
And then you can combine stuff.
Can I? All right. Whew. This is scary, guys. I'm scared. I don't know about you. This is scary. Let's combine some like terms. 2 sinx minus 1 sinx is sinx. So I've got sinx. Yeah, I am, sorry.
Plus 1.
2 cosx minus 1 cosx is plus 1 cosx. Minus sine squared over cos x. I mean, I'm trying to think of like, I wonder if I should just leave that for now. I have a feeling I want to just leave that. Yeah. I mean, I could try to rearrange it, but I don't think it's going to necessarily gain me anything. I mean, if I somehow had both of these over a common denominator, I could see possibly trying to get a Pythag there, but I don't think that's actually going to happen. So I think this might be as far as I need to go on the left. Let's see what happens on the right. So let's distribute. Cosx times 1 is cosx. Cosx times cotan x. Didn't we calculate that a moment ago? That's the cos squared x thing, right? And it's minus over sinx. I think I've got it here, guys. Sinx times 1 is going to be plus sinx. Oh. And sinx times tanks. Sinx times tanks is going to be this, right? That's going to be that term there. And I think those are equal, right? This guy is the same as that guy. It's not pretty, for sure, but I'm going to say verified. Right, look at all my terms. They all match up, right? You guys agree? Right, I've got a sine x here and a sine x there, a cos x here and a cos x here. Here a cos, there a cos, everywhere a cos cos. Yeah, we're good. And the sines are all right. Good, 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 good. So yeah, that problem's a little crazy. But thanks for watching, Internet friends. Have a great day. Bye-bye.